Okay, so here's where I was talking about, I think earlier, the difference between theoretical probability and they use the word empirical. I use the word experimental. So the difference between this one and this one, theoretical probability, or what the textbook calls classical probability, is you're not actually doing it. You're just looking and thinking and talking about it. So here's a spinner right here. I'm just looking at that spinner. I can't spin it because it's not actually a physical spinner. So all I can do is say, well, it looks like this spinner has 4 different colors. So I can say, I don't know, this might be yellow. So I can talk about the event landing on yellow. I could look at this and say the sample space is 4 because there's 4 different outcomes. And if we were looking at it as colors, then we would call red, blue, green, yellow. Or if we put numbers in here, then the sample space would be 1, 2, 3, 4. All right, so that's theoretical probability. Experimental probability is you're actually doing it. So this is experimental, or what they call empirical, because I'm going to spin the spinner, okay? And I'm going to see the outcome of it. I could also, I think my other options here are to flip a coin. Let's see. Yeah, coin flipping. I don't know what this probability of heads. Let's just see, compute what happens. Oh, I don't know. I don't know what that is. I'll close it. But here is I'm actually spinning the spinner and recording what happens. I'm spinning the spinner and I'm recording what happens. Okay. So this is experimental. And the difference between the two probabilities, both of them, notice that the probability of an event, okay, that's how we write it. The capital letter P stands for probability. E is whatever event. They're going to name them event A, event B, event heads, event tails, event Queen of Hearts. I mean, they're going to do, whatever the event is. They could name it with a capital letter. They could just name it with a word. But here's the difference. If you're dealing with theoretical probability, the fraction, notice this is a fraction, this is a fraction, they're both fractions, okay? The difference is what number goes on top, what number goes on bottom. If it's theoretical probability, you put the number of outcomes in event E on top and the number of outcomes in the sample space on the bottom. So it's the part that you're looking for out of the total sample space. So if we're talking about theoretical probability right here, and let's say that I define this spinner right here, my event that I'm interested in is landing on 1. Okay, so event A would be 1. So we'll just say, no, let's see. Event C is defined to be landing on 1. All right, so that's what I'm interested in. Now, how many ones are there on this spinner? Well, there's just one spinner, so the probability of event C happening is going to be 1 because there's only one out of a total of 4 because there's 4 numbers in my sample space. Remember, my sample space here, my sample space is 1, 2, 3, 4. Or if it wasn't numbered, it would be red, blue, green, yellow. If I had a different spinner, I don't know how many I'm going to come out with. 1, 2, 1, 3, 1, 4. Okay, there's a different spinner. My sample space here is 1, 2, 3, and 4. There's my sample space. Notice I didn't count my ones twice. 1 is is a thing that I could land on. It doesn't matter that I have 3 of them. 1 is in my sample space. Okay, and if I'm here, if I'm looking for event C, C is still landing on 1, then the probability of C here would be I have 3 ones out of 1, 2, 1, 2, 3, 4, 5, 6. Oh, I think I do put 6 on bottom. So maybe I do list the ones again. My sample space would be 1, 1, 1. 1, 1, 1, 2, 3, 4. I'd have to list them all, because if I didn't list them all, because the probability of me landing on ones is a half, because half of these numbers are, so yeah, I do need to, I was wrong there. My sample space does need to be 1, 1, 2, 3, 4. You do count the repeats. So that has a total of 6 things in my sample space, and the event of landing on a 1, that could happen 3 times, so it's 3 out of 6, and that reduces down to 1/2. So that's the probability, and both of those are theoretical probability. Experimental probability, I put the frequency that the thing happened. Okay, that number goes on top, so I'm going to count how many times it happened, and then out of the total number of things that happened on bottom. So we're going to run over here real quick to this right here. I've already spun the spinner 8 times, so since I spun it 8 times, then right here I'm going to put 8 on bottom because I spun the spinner 8 times. And then I'm going to say, okay, how many times did it land on 1? It just landed on 1 time. So since it landed on 1 time, the experimental probability of event C happening, and we defined C to be landing on 1, that was only 1/8. If, let's say, let's go ahead, because I thought 2, it landed on 2 many times. So let's let event D is going to be landing on 2. Okay, so event D is landing on 2. So if I wanted to find the probability of event D happening, I spun the spinner 8 times, so the 8 goes on bottom. And now let's go look and see how many times it landed on 2. 1, 2, 3, 4. It landed on 2 4 times. So I come over here and put 4 on top. 8 was how many times I spun the spinner, and that reduces down to 1/2. So the 2 different formulas are just based on whether or not did you actually collect the data. Are you just talking about what could happen? Did you actually do it? Did you flip the coin 5 times and write the results down? Or are you just talking about what happens if you flip the coin 5 times? So that's the differences of those 2 things. We can use frequency tables, and that's what this is right here. Here's the responses that we could have had right here. Some survey, and I don't know what they asked them, but maybe how many dogs you have, or it could be how many kids you have. And I don't, they obviously asked 2,225 people, because if you add all those numbers up, that's how many you get. So that's the number that goes on bottom, because that's how many surveys we had. And then for this one, I'm interested in the event of answering 1. Okay, so the probability of that happening, how many people answered 1? 205. Out of a total of how many? 2,225. So this is an example right here of empirical. Because this is the results of a survey. We didn't just talk about, well, if I asked, 500 people, my answers could be. No, we literally asked 2,225 people. Or maybe we asked more, but that's the number that we got back. Okay, so just be sure you understand the difference between those two definitions of finding the probability. But I always remember it's part over whole. The little number goes on top, the big number goes on bottom. And that's always going to be that way, because we'll learn in just a second right here that probability is always a number between 0 and 1. And so when you're dealing with a fraction, if you put the big number on top, you're going to get a number bigger than 1. So the little number goes on top, the big number goes on bottom. If you don't do it that way, then something's either wrong with your sample space, or it's wrong, you got too many outcomes in your event, or you've done it upside down, or something else is wrong. But your probability should always be a number between 0 and 1. So this did come out of your book. So, and this is a question. I think it's even a question on your final. So this is kind of a big deal. You might want to star this right here. Probability of an event is always between 0 and 1. If it is absolutely positively not going to happen, then the probability can be 0. For example, if I went and tried out to be a Dallas Cowboy cheerleader, the probability of me making the team is absolutely 0. 1, I'm old. 2, I'm chubby. 3, I have no coordination whatsoever. Can't dance, none. So I am not going to make the Dallas Cowboy cheerleading team. So that's impossible. If it's absolutely going to happen, then the probability is 1. That's like my dad has this funny thing hanging outside on his porch, and it says a weather indicator, and it's, I don't know, like a piece of rope or something, and it says touch the rope or something like that. If it's wet, it's raining. If it's frozen, it's freezing. If it's if it's flapping in the wind, it's windy. I mean, so if it's pouring down outside, the chance of rain is 100%. It's certain. It's absolutely going to happen because it's happening right then. So everything else is going to be somewhere in between. You do need to be familiar with these terms, because it's going to ask you after you do some calculations, it's going to say, is that a likely outcome? Well, if it's somewhere right around here, around 0.75, a little bit bigger or a little bit smaller, then that's considered a likely outcome. If you got a probability of 0.1, then that's definitely unlikely, okay? So they're going to ask you to describe it. Is it likely? Is it unlikely? So you do need to be familiar with this scale right here. I am not going to cover this one right now. I will stop the video and do it in one more video from this section.